Jupiter's moon, Europa, is a fascinating world with a salty, subsurface ocean.
Water covers 71% of Earth's surface, and it's crucial for sustaining life. We're so accustomed to seeing water all around us that it's easy to forget that the rest of the solar system doesn't have this resource in abundance. However, that's the reality. Researchers have been searching far and wide for any signs of water within our galaxy, and their efforts have finally paid off. NASA recently announced a groundbreaking discovery made by the James Webb Telescope. It detected not just water, but a whole ocean on Jupiter's moon, Europa. This discovery holds significant implications for the potential habitability of Europa's ocean. In this episode, we will delve into the sign of life on Europa. This is Reveal the Mystery. If you are curious to learn mysteries of the world, space and beyond, consider subscribing. How JWST detected carbon dioxide on Europa's surface. Let's begin with the methodology employed by James Webb in the detection of carbon dioxide on the surface of Europa. James Webb, as you may be aware, is not merely a solitary telescope. It comprises a sophisticated system of mirrors, cameras, spectrometers, and detectors operating in tandem to capture and scrutinize light emanating from distant celestial objects. For the purpose of observing Europa, James Webb made use of two of its specialized instruments, NIRCam and NIRSpec. NIRCam serves as the principal camera in the James Webb system, adept at capturing high-resolution images within the near-infrared spectrum. Notably, NIRCam comprises two distinct modules, a wide-field imaging module and a chronography module. The latter employs a technique known as chronography to block the intense luminosity emanating from stars or planets, thus enabling the observation of fainter objects nearby. In this particular case, NIRCam's chronograph was pivotal in suppressing Jupiter's luminosity, allowing for a clear focus on Europa. This observation was carried out on January 9, 2023, coinciding with Europa's closest proximity to Earth. James Webb, equipped with its substantial 6.5-meter primary mirror, was meticulously oriented toward Europa for a duration of approximately 10 hours. During this time, data was meticulously collected from both NIRCam and NIRSpec. The instruments employed by James Webb covered a specific wavelength range spanning from 0.6 to 5 micrometers, encompassing both visible and near-infrared light. It's worth noting that the spectral resolution achieved was an impressive 1,000, indicating that the range was finely divided into 1,000th of the wavelength spectrum. In terms of spatial coverage, the observation encompassed roughly 12% of Europa's surface area. What JWST has found on Europa's surface? Now, let's talk about what James Webb found on Europa's surface. They discovered carbon dioxide in a specific spot on the icy surface of Europa. Carbon dioxide is a gas made of one carbon atom and two oxygen atoms. It's a common and important molecule in the universe, playing vital roles in things like plant growth, breathing, and how living things use energy. It also works like a blanket, trapping heat and affecting the temperature of a planet. So, how did this carbon dioxide get to Europa's surface, and why is it only in one place? It's likely that this carbon came from Europa's deep underground ocean, which could be a home for life. This ocean is incredibly deep, about 100 kilometers deep, with more water than all of Earth's oceans combined. Jupiter's gravity squeezes and heats up Europa's insides, keeping this ocean liquid. But there's a layer of ice, about 10 to 30 kilometers thick, separating the ocean from the surface. This ice isn't smooth and steady, it's always changing and breaking. There are cracks and openings in this ice layer that allow water and other stuff to move between the ocean and the surface. Sometimes, big impacts or eruptions can create holes or sprays in the ice, letting things move between the ocean and the surface more easily. The carbon dioxide James Webb found might have gotten to the surface in different ways. It could have dissolved in the ocean water and then turned into a gas or ice, when things like pressure or temperature changed, or it might have been made by chemical reactions or living things in the ocean and then brought to the surface by ocean currents or jets. This carbon dioxide-rich area is close to Europa's equator and covers about 12% of its surface. It's called chaos terrain because it's a jumbled and complex landscape with ridges, cracks, blocks, pits, domes, and low spots. This region formed because of the way the ice and the ocean interact, causing the ice to melt, freeze, break, and change, creating this chaotic terrain. It's also one of the most active and diverse areas on Europa, making it a great place for James Webb to study. Why carbon dioxide matters for Europa's habitability. So why is this discovery significant when it comes to Europa's potential for supporting life in its ocean? The presence of carbon dioxide on Europa's surface hints that there might be organic molecules or even signs of biological activity in its deep ocean. Now let's break this down further. Organic molecules are compounds containing carbon, and they're essential for life as we know it. Biological activity refers to any processes involving living organisms or their products. This discovery is crucial for both organic molecules and biological activity. Carbon dioxide can react with water to create carbonic acid, which then breaks down into bicarbonate and hydrogen ions. These ions can influence various aspects of the ocean, such as its pH level, salinity, temperature, and circulation. This, in turn, creates different chemical environments that might be favorable for various types of life forms. Additionally, carbon dioxide can react with other elements or molecules to form more complex organic compounds like sugars, amino acids, nucleotides, and lipids. These compounds are the building blocks of life, forming carbohydrates, proteins, nucleic acids, and fats. They can also store energy or information that living cells can use. Furthermore, carbon dioxide can be consumed or produced by biological activity in the ocean. For example, some microorganisms can use it as a source of carbon and energy through processes like photosynthesis or chemosynthesis. Detecting carbon dioxide on Europa's surface can help us better understand the chemistry and dynamics of its ocean. By measuring the amount, distribution, isotopic composition, and changes in carbon dioxide on Europa's surface, we can learn about the carbon content in its ocean, how it moves between different forms and locations, its interactions with other elements or molecules, and how it affects various physical and biological processes. This information can also guide future missions to Europa, such as NASA's Europa Clipper. This spacecraft will fly by Europa multiple times, investigating its geology, composition, and environment. It will carry a suite of instruments, including cameras, spectrometers, radars, magnetometers, and plasma detectors. Additionally, a lander will touch down on Europa's surface, conducting measurements and experiments. The data from James Webb's observations will help select the best targets and strategies for Europa Clipper's exploration. It will also contribute to testing the hypothesis that Europa's ocean could potentially support life and aid in the search for signs of life on this intriguing moon.